Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how to use molarity as a conversion factor in the stoichiometry process. So if we're using a chemical equation, then we can use molarity to help us convert from one thing to the other. So let's get into this. So again, previously in other problems I've done, we do a mass to mass conversion where we are given a unit of mass and we convert from that unit of mass to grams if we don't have grams, and then to get the moles. And then from here, you can use the mole ratio in your balance equation and then go from there. So remember, the goal here in a stoichiometry problem, the first thing you need to do is figure out how you're going to get to moles of your substance, because then you will be able to use the mole ratio to convert to a different substance in your equation and go from there to whatever unit they want. Now, in this case here, we're not going to be doing a mass to mass, but we're going to be doing a mass to volume. So here, we're going to have to use our molarity in some way to go from either grams to or moles to volume, or volume to moles in some way. So in this problem here, they're asking what is the maximum number of grams of silver chloride that will precipitate from a solution made by mixing 25.00 milliliters of 0.050 molar solution of magnesium chloride with an excess of silver nitrate solution. Okay, so here they want grams, but they're giving us volume and molarity to start with. So whenever they give you molarity, you should be thinking conversion factor. So because we are given molarity, which has the units of moles per liter, and so that screams conversion factor, so that we can use that to convert between moles and liters. Okay, so what are we going to begin with though? We have to begin with the volume that they give us, 25.00 milliliters. And one thing I want to point out is that this is not a limiting reagent problem, and I know that because they're telling us that the magnesium chloride is reacting in excess of silver nitrate. So we have an excess of silver nitrate, so which means that the magnesium chloride is going to react to completion. So we don't need to worry about figuring out what's the limiting reagent and all that stuff. So we're going to start with our 25 milliliters. So we have 25.00 milliliters of the MgCl2, so magnesium chloride. So we're going to start with that. And we're going to use our conversion factors to convert from the milliliters of magnesium chloride all the way to the grams of the silver nitrate that we need, okay, or the silver chloride. Now, before we go on, we need a balanced equation. So stoichiometry needs a balanced equation. So I think I got a little ahead of myself. So let's write out the balanced equation first. So the two reactants that we're given is magnesium chloride, so MgCl2, and that's going to react with, and this is aqueous, and that's going to react with what? They are giving us a silver nitrate solution, so that's going to be AgNO3, and that's going to be aqueous. And notice we have two ionic compounds, aqueous, so this is going to be a double displacement or double replacement reaction. So we're going to put the two outer ions together, magnesium and nitrate. Magnesium is a +2, nitrate is a -1, so we're going to need two nitrates to balance the charge on the magnesium. So let's go ahead and do that. So that's going to be Mg NO3, 2. Okay, and then the two inside ions are going to go together. So the silver and the chloride are going together. So silver is a +1 charge. Chloride ion is a -1, so it's 1-to-1. So then that's going to be AgCl, and that's going to be our precipitate. Nitrates, that's going to be aqueous. All nitrates are soluble, so we'll have to have aqueous here, and we're going to add to that. So now we have our equation. Now we need to balance it. So let's balance the metals first. So I have one magnesium. I have one silver. So the metals are balanced. Let's go to the nonmetals. So I have two chloride ions here. I have only one there, so I need to put a 2 here. But then I need to rebalance my silver. So I'm going to have to come here and put a 2 there. Okay, silver is now balanced again. My chloride, two chlorides. And then what about nitrates? I have 2 nitrates here and I have 2 nitrates there. And so everything's balanced. So I have my balanced equation. Now we can go ahead and do the stoichiometry. So again, I'll start with the 25 milliliters. So here we have 25.00 milliliters of the magnesium chloride solution. Well, we can put in solution in here, so to make it sure that we're talking about the solution. And then that's going to be over 1. And so the next thing is to convert to what? Well, here I'm given milliliters of the solution. So that's volume, units of volume. I need to convert that to liters. And then I'm going to use the molarity to convert liters to moles. So let's go ahead and do those 2 steps. So here, I'm given I need to convert to liters, so I know that 1 liter is equal to 1,000 milliliters. So I'm going to put 1,000 or 10 to the 3 on the bottom. So that's going to be milliliters of the MgCl2 solution. And then here on top is going to be 1 liter of the MgCl2 solution. So the milliliters cancel out. Now I have liters. So now I can use the molarity to convert to moles. So what's the molarity? 0.050. So that means I have 0.050 moles per liter. So I'm going to write that. So I have liters on top. I'm going to have 1 liter here on the bottom, 1 liter of the MgCl2 solution. And then on top, I'm going to have the 0.050, oops, not 2 points, 0.5, 0.050, and that's going to be moles of the MgCl2. Okay, so now the liters of the solution cancel out. Now I have moles of magnesium chloride on top. So now that I have moles, I can use the mole ratio to convert from moles of MgCl2 to moles of the silver chloride, because that's what I'm interested in. I'm interested in the silver chloride. So now I'm here. I'm going to use the mole ratio to convert to the second substance, silver chloride. So what's the mole ratio? 1 mole of magnesium chloride to 2 moles of the silver chloride. So I'm going to go ahead and do that. Okay, so let me make that longer. So on this side, I have 1 mole, I have moles of magnesium chloride, so I'm going to put 1 mole of magnesium chloride on the bottom. So 1 mole of MgCl2 on the bottom, and then 2 moles of the AgCl on top. 2 moles AgCl on top. So now moles of the magnesium chloride cancel out. Now I have moles of silver chloride. I am now here at moles of substance 2. Now they want grams. So I'm not going to go this way. I'm going to go this way to grams. Well, how am I going to do that? I need the molar mass. So I need to calculate the molar mass. So let's calculate that. And that's 143.32. So I'm going to write that down here. So I'm going to continue. So I have moles of AgCl on top. So I'm going to put 1 mole of AgCl on the bottom. And the one, what was it? 143.32. 143.32 grams of AgCl on the top. So the moles of AgCl cancel out. Now I have grams. Grams is what they're asking for, grams of the silver chloride. So I've got grams. So now all I need to do is multiply across the top and divide by everything on the bottom, and I get my answer. So when I do that, I get 0.3583. So what was that? 0.3583 grams of the silver chloride. Now, this is the amount of silver chloride that will be precipitated from this reaction. So now with regard to sig figs, for those of you who are interested in sig figs, well, how many sig figs should I have? My answer, remember the rule for multiplication and division is that the number of sig figs I have in my answer must equal the least number of sig figs, or I should equal the number of sig figs in the measurement that has the least number of sig figs. So we're going to ignore the exact relationships, right? So milliliters to liters, that's exact. So we'll ignore that. Also, the mole ratio is exact. So we'll ignore that. So we're going to look at the molar mass. Here we have 5 sig figs. Also, the molarity here, or that they gave us, that has 2 sig figs there. So, and then here we have 4. So the least number of sig figs is going to be 2. So that means our answer should be rounded to 2 sig figs. So that's going to be 3, 5. We're going to cut it off there. So this 8 means that we're going to have to round this to a 6. So the final answer is 0.36 grams of AgCl. So that is our final answer. Thank you for joining me. I hope this video helped you. If it did, then please like the video, share the video with your friends. Make sure you hit that like button. Also, subscribe to my channel, hit that notification bell, and when you do, make sure that you click all so you can be notified by all the videos I put out. And then finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a question you want me to answer or go over, if you have a problem you want me to help you solve, or if you have a topic you want me to cover, let me know. I would love to do that for you. Thanks for joining me and have a great day.